Hello everyone, Matteo here. Today I'm going to have some fun with AnimateDiff. I'm trying to find a way to make animation tutorials because there are many kind of animations and each one has to be approached differently. There's no one way to do animations, and also the same problem can be solved in different ways. So I feel that a generic animation tutorial doesn't really exist. So I thought of doing this project-based. Today I'll show you how I did this animation, and I hope you'll find some inspiration in the process. Before diving into it, I wanted to give you some update on some nodes I'm working on. You probably remember this workflow from a previous video of mine. And to reach this result I have to create a mask with a video software like Premiere or Kdenlive. This can be a tedious process because, for example, if you need more frames, you have to regenerate a new mask animation. So to solve this problem, I've created a transition mask node that basically generates basic mask animations with very little effort. So you can set the size, the number of frames, and various other options. Let me show you. I have a mask preview node also. So this same animation can be done with transition type center box. Q prompt and it's done. If I need 32 frames, no problem. If you want the animation to start at the 16th frame, for example, instead of the first, you can set the start frame at 16 and now the animation starts later. In the same way, you can end the animation earlier, setting the end frame. And this is a very simple way of having quick and dirty transition masks. You have a few options for the kind of animation you need. A very useful one is fade, of course. And you can mix this with many other nodes like invert mask that gives you a negative of the original animation. Another interesting one is mask expand batch. Let's say you have 4 frames. This node will expand your 4 frames to 16 in this case. Or you can expand them by repeating, or by simply adding frames at the beginning or at the end. There's also another node that you might find useful, and it is mask blur, that basically just adds some feathering to your mask. Be careful with a lot of frames and with a very large blur amount, because this is a Gaussian blur, so quite demanding. These nodes are all part of the ComfyUI Essentials. We are not going to use transition mask today, but I wanted to show you anyway because I think it's very useful. So let's go back to our Jellyfish Ballerina. So this is the simplest AnimateDiff workflow. It is only conditioned by the prompt, which is beautiful ballerina dancing like a jellyfish, underwater photography. It is too little to generate anything meaningful, but let's give it a try anyway. This is better than what I anticipated, but of course we have no control over this. The model generated this animation randomly, and instead we want a very specific kind of animation. In the parameters I have nothing weird. I'm only using UniPC BH2 sampler because it's new and I wanted to try it, and a V2 AnimateDiff model. The main checkpoint is Dream Shaper. So I have a very nice animation that I want to try to replicate or at least take inspiration from. I use a load video node. This is the ballerina video. And since I'm going to do a lot of tests, I'm capping the frame number to 16. Conveniently, I have a frame count output in this node. So I'm converting the batch size in my latent to an input and connecting the frame count to the latent node. So now every time that I change the frame number in this node, the latent size is also updated. As you can see, I'm using an empty latent. This is not going to be a rotoscoping image-to-image kind of video, but I like the movement of the dancer, so I'm using an OpenPose ControlNet to try to replicate this dance. I'm adding a pose preprocessor. DW preprocessor is a very good one. I connect it to the source video and check the result in a preview image. This looks good, but the character takes only about half of the frame, so it's a bit small. To increase the input data quality, I'm setting the resolution a little higher, 768. I also probably don't need the face. And now it should work. Now we need an apply ControlNet advanced. I connect the animation, positive and negative, and of course the ControlNet model. Open pose, then to the key sampler. I'm lowering the strength. It's always good to give some freedom to the model, and we are ready to see what we've done. Okay, now things are starting to get interesting, but we have a long way to go. I bet if I increase the number of frames to 32, for example, I will start getting some artifacts, especially in the anatomy. Let's try. Yeah, this is very bad. To add more stability, I probably need another control net. And I'm thinking line art. So I'm copying this one, connecting the two together, again to the key sampler. I don't need the preview anymore. And here I'm loading line art. Now I need to process the video with line art preprocessor, and I send this to the new control net. Since line art is a very strong control net, I'm going to lower its influence even further. Instead of lowering the strength, I'm changing the time stepping and setting something like 0.7 in the n% field. This means that starting from 70% of the generation, the control net will be ignored. Let's see. Now the animation is still very blurry, but the anatomy is much better. Let me set back the number of frames to 16. And now we need to give some stability to the animation and sharpness to the image. To do that, of course, we are going to use IPAdapter. I need the IPAdapter model. I'm using a plus model that usually is the only one with enough strength to counterpart AnimateDiff blurriness. The clip vision, we intercept the model pipeline, and now we have the first problem. As you know by now, clip vision only works with square pictures, 224 by 224 pixel size, but our video is in portrait mode, so how can we send this reference to the IPAdapter without losing too much resolution? Well, luckily IPAdapter supports attention masking. This means that we can split the video into two parts, the upper and the lower, and send them separately to two IPAdapter nodes, one masked on the top and one masked on the bottom. Let me show you. First of all, I'm scaling down the source with an image resize node. This is part of ConfigUI Essentials. It is very close to the default image upscale node, with the difference that I have a keep proportion option. So I can set a size. I'm setting 488 by 488, and no matter what is the source video resolution, the image will be scaled proportionally. Now I'm going to crop the image into an upper and lower part with image crop. I'm using the plus one, which offers more options. This will be the top and this will be the bottom. The clip vision works at 224, so I'm already grabbing the right size. And as crop position, I'm selecting bottom center. For the upper part, I'm selecting still bottom center, but with a Y offset of -224. Let me disable the final process and put a preview here. So as you can see, in the bottom batch, I have the legs, and in the upper batch, I have the torso and the head. I'm selecting a better interpolation, and since the video is at 1080p and I resize it quite a bit, I'm also adding a little bit of sharpening before sending it to the clip vision. I'm using cast sharpening that is also available in the ConfigUI Essentials. So now that I have the images ready, I need to create the two masks. I'm creating an empty mask. The resolution is 512 by 768. And I need a second one that is half the height and it's white. Now we combine them with mask composite. The destination is the full size black mask and the source is the white mask. The operation is add, position 00, and we can preview the result. So now we have a mask that is basically active only on top. We can remove the previews and send the result to the first IPAdapter. And this node will be responsible for the head and the torso. Now we copy the IPAdapter. With Shift Ctrl V, we get the node with all the pipe connections. We connect the first to the second to the K-sampler. The image is for the legs. And now we need to invert the mask and send it to the new IPAdapter. We are also lowering the strength, 0.7, and adding a little bit of noise. Now, since there are elements in the image that I don't want, like the stairs and the door, I will also try to play with time stepping. Let's start with 0.7. So the IPAdapters will be disabled at the 70% of the generation. And finally, this is very important, we have to enable unfold batch. That basically is responsible of sending our reference animation one frame at a time instead of everything in one batch. I'm enabling the output, and let's hope I didn't do something stupid. And now we have an incredibly stable animation without flickering, and I like that there's a jellyfish here in the window. Remember that this is still not video to video. The IPAdapter is only used to stabilize the animation, but the reference video is never sent to the latent space. So this is cool, but there are elements that I do not want, like the stairs and the window, and I want more freedom in generating anything around the ballerina. The thing that is influencing the generation for the background at the moment is the line art ControlNet. So there's a little bit of trickery we have to do to cut out the background from the character. Fortunately, we have very good segment preprocessors. One of them is Oneformer Coco, but depending on the subject, you may need to experiment with all of them. We send the video to the preprocessor. I'm disabling the output for now and previewing the result. Now that all elements are segmented, I can try to select the ballerina. I have a very helpful node called Mask from Color. This is again part of the ConfUI Essentials. I know that this red is 220, 60, 20, and this node will convert only that color to a mask. It's actually 220, 20, 60. As you can see, there's a little bit of noise. That is because the red is not a solid color, so I can set a threshold to the mask from color, and now the full mask is selected. I don't need the preview anymore. Now, there are many ways we can use this mask to filter the content, but I think that the easiest is to basically cut out the character using this mask and making all the background black. It is probably not the easiest to do, but it is the lightest computationally speaking when you go to the K-sampler. So first of all, I'm growing the mask a little by 1 pixel. Then I'm also blurring it with mask blur. Then I need an empty image. I'm converting the batch size into an input and taking the frame number from the animation. I'm scaling down the video to 512 by 910 and the color is 0 for black. Then I need an image scale node, 512 by 910, and connect the video to it. Then I'm compositing the two with an image composite masked. The black image is the destination, the scaled down video is the source, and the mask is the one that we've just created. Position 0, 0. Let's see if I've done everything right. And as you can see, now we have our ballerina with just a black background. This can now be sent to the line art preprocessor. And we finally got rid of the stairs. We don't need the preview. Reactivate the output and see if it works. We still have the window because the IPAdapter is still a very strong conditioning, but we do not have the stairs anymore. Now all we have to do is to reintroduce the jellyfish. And to do that, I'm using a third IPAdapter. Let me daisy chain everything. The reference image this time is a jellyfish. This is used as a conditioning for the whole animation, so I don't need the unfold batch. I want this to be a very strong conditioning, so I'm setting the weight back to 1 and also disabling the time stepping. Since this is a big picture, I'm using a prepare image for clip vision, so it will be processed at a higher definition. I think this should be all. Of course I have to remove the mask, and let's see how it goes. And now we have this incredibly suggestive video with a jellyfish and this wonderful transparent skirt. But how can we improve this? So first I want to try with a new node that was actually released for SVD, I believe, and it's called Video Linear CFG Guidance. I'm setting this to 3. So what this node does is to gradually reduce the CFG scale from the original in the K-sampler to the one that is specified. And I don't know if this is the right way of using it, but I always like to experiment and to try different things. So we have this option. In theory, it should work. So let's give it a try. So since the CFG is modulated now, you get this glowing effect. And I think that it goes well with this kind of animation, so I think I'll keep it. Now the video is a bit blurry and it will get blurrier increasing the frame count. So I'm trying to reintroduce some details with a second pass. I copy the K-sampler, connecting the first to the second. I'm lowering the denoise to 48, also the CFG 4.5, and changing the seed. Everything else should be fine. And now we got some sharpness back. So at the moment we have only 16 frames at 8 frames per second. And of course I want the video to be a little more fluid. So I'm using interpolation to increase the frame count. There are many models for that, and this time I'm trying with Rife. Let's see the difference. And now it's much more fluid. Ah, beautiful. Finally, we can upscale. I'm adding some sharpening since I hammered it. 0.25 is more than enough. But since upscaling is quite expensive, I am upscaling first and I will apply the interpolation later. So sharpening, upscale by model, then I'm scaling it down because the model is a 4 times upscaler, and finally it goes to the interpolation. Let's see. And now the animation is large and sharp. Just for fun, we can try with another jellyfish. The other was more colorful, but I really like the light that happens at the end, and it also illuminates the face of the dancer. Very cool. Okay, now I want to render the final animation with a higher frame count. I'm getting back the other jellyfish, setting 64 frames. And since AnimateDiff models are usually trained at 16 frames, we need a context window. Basically with this node, the 64 frames will be split into chunks of 16. I'm lowering the overlap since we have a lot of conditioning, and I think that we can give it a try. What happens now is that I get an error because none of the default ControlNet node is compatible with the context window. So what we have to do is to replace the ControlNet node with one compatible with AnimateDiff. One is Advanced ControlNet Apply, and we are also using another Load ControlNet model. And we need another for the line art ControlNet. Cool. If I did everything right, in a few minutes we should have a 64 animation and actually 128 at the end. And this is the end result. The only difference is that I've changed the sampler. I'm using now DPM++ to MSD GPU because UniPC was smoothing the image too much. And maybe the result is nothing special, but I believe we've learned a couple of important things. One is how to remove the background from the reference video so only the main character can be used as reference in the ControlNet. And the other is how to tile an image that is not a square to be fed to multiple IP adapters. I found covering such complex topic in under 20 minutes very difficult, so I had to skip on some details, and also some steps could be probably done differently, but this is meant just to whet your appetite and get you started. Hope you found this video interesting, and yeah, if you do anything cool with this workflow, please let me know. You can find me on Discord, and I'm looking forward to seeing your animations. I think it's all for today, and see you next time. Ciao. Oh, hey, still here? I've tried to make background music with AI for the Jellyfish Ballerina, and this is the result.